Okay, thank you. Good morning, each and everyone. This is basic mathematics from 2. The topic called the logarithm. Logarithm. The one who is introducing this topic, I'm called TR.GERALD George from St. Maximilian Secondary School. Now let us go directly through our topic. Our topic, as I've told you, it is called logarithm. As you can see, definition. We know in mathematics we cannot define something directly. We always define something according to the laws as well as rules. So there is no a direct definition of anything in mathematics. Now, what is logarithm? We are going to see now. I have given, there is a certain example here. We have 2 power 6 is equal to 64. This is very true from the topic of exponents. When you take 2 power 6, you will get 64. It is true. Because 2 times 2 times 2 until they reach 6. When you multiply this one, you get 64. It is true. But this is always called the exponent. This is always called the exponent. This is always called the base. And this 64 as usual. Now, this exponent 6 is called the logarithm. In terms of logarithm now, you know this topic of logarithm is directly defined from the topic of exponents and radicals, especially exponents. That's why I've given you the certain example in starting that 2 power 6 is equal to 64. Now, how can we write this one in terms of logarithm? The exponent 6, this exponent 6, is called the logarithm of 64 to base 2. Now, this is the exponent. 2 power 6 is equal to 64. This is true. In terms of logarithm, how can we define this? We always say the exponent 6 is called the logarithm of 64 to base 2. That's what I've written here. The exponent 6 is called the logarithm of 64 to base 2. In short, is written as 6. This is 6 is equal to the log of 64, but base 2. 6 is equal to the logarithm of 64 base 2. And we always, when we write this log, means logarithm. We never write logarithm in full. No, we write log. Log, it means the abbreviation of logarithm. So when you write log, this means logarithm. Now, for example, look here. You can have 2 power 3. We all know that 2 power 3 is equal to 8. It is true. 2 power 3 is equal to 8. This is the exponent. But how can we write this one in terms of logarithm? How can we read this one in terms of logarithm? This is the exponent, this is the base. So we say the exponent 3 is called the logarithm of 8 base 2. The exponent 3 is equal to the log of 8 base 2. It means in terms of logarithm now, how can we write this one? We start with the exponent. We start with the exponent that 3 is equal to log of, this is 8, base 2. This is in exponential form in terms of exponent. This is in logarithmic form in terms of logarithm. When we have 7 power 2, we all know that 7 power 2 is equal to 49. This is in exponential form. It is in the form of exponent. But how can we read this one? Or how can we write this one? In form of logarithm or in logarithmic form? We start with the exponent that 2 is equal to log of this 49 base 7. So this is in exponential form, this is in logarithmic form. That's what I have tried to explain here. Thank you. That's what I was trying to explain here. That, for example, 25 is equal to 5 square. It is true. 5 square is equal to 25. This is in the form of exponent or exponential form. But how can we read, or how can we write this one in terms of logarithm? We start with the exponent. That the exponent 2, this exponent 2 is equal to log of 25 base 5. 1000 is equal to 10 power 3. This is very true in terms of exponent or in exponential form. But how can we write this one in logarithmic form? We start with the exponent. Don't forget, we start with the exponent that 3 is equal to log of 1000 base 10. Remember, this is the base, this exponent. So even if you change this one in logarithmic form, the base remains to be the base. no matter it is in exponential or it is in logarithmic form, the base remains to be the base. That's why here, this is the base, this is the exponent. Now, even if we write in the logarithmic form, the base was 10, now the base also would remain as 10. But what do we start with? We start with the exponent. 3 is equal to log of 1000 base 10. You can have a second example also. You can maybe have 80 power 2 is equal to 64. We know 80 power 2 is equal to 64. This is in an exponential form. But how can we read this one? How can we write this one in a logarithmic form? We start with the exponent that 2 is equal to log of 64 base 8. Now, this is in exponential form. This is in a logarithmic form. That's what we are talking about. Now, let us see example number 1. Let us go direct into example number 1. Example number 1. Change the following exponential form into logarithmic form. We have given these ones. These are in exponential form, as you can see. These are in exponential form. But we are changing this one into logarithmic form. Let us start with with A. A we have given 5 power negative 3 is equal to 1 over 125. It is in exponential form. But the question is to change this one into logarithmic form. Now, in logarithmic form, this will be, as I have told you, we have to start with the exponent. It means it will be negative 3 is equal to log of, this follows, 1 over 125. Since this is in fraction, it's better we put the bracket. But base 5. Remember, we have said to put the bracket because this is in fraction. If the fraction could not be there, no need of brackets. But since we have the brackets, it's better we introduce we have the number in fraction, it's better we introduce the what? The brackets. But we always start with the exponent that negative 3 is equal to log of 1 over 125 base 5.